Hello, this is Teresa Adams with Community Colleges of Denver. Today what we're going to talk about is angular velocity. When we're talking about angular velocity, the motion we're talking about is circular motion. It's going to go through some angle alpha radians and some given time t. Then if that's true, then it's angular velocity omega. That's that funky looking W right there. Yeah, let me get my pen. Right there. Nope, that's not what I wanted to do either, so hang on a minute. Right? Try this one more time. Right here. Then that's omega. Omega is given by our angle in which we've gone around, so our angle alpha, over some given time t. So let's look at example number 1. We're going to look at a radar antenna. It's going to make 1 revolution in 2 seconds. What is its angular velocity? So I have 1 revolution divided by 2 seconds. Now I need to convert that into radians, because our unit is radians. When we look at omega, it's in radians. So I know my unity conversion from before is going to be 2 pi radians, 1 revolution. So my revolutions will cancel out, my 2's will cancel out, and I'm going to be left with pi radians, that's my angle, divided by my time, which is seconds. So my answer is pi radians per second. Now if we look at example number 2, we have a blade of a windmill that is 30 feet long and rotates 90 degrees every 30 seconds. It wants the radians per minute and revolutions per minute. So let's do the revolutions per minute because that's more straightforward. So if it takes 30 seconds to go 90 degrees, then it's going to take 1 minute to go 180 degrees. That's half a revolution. So that means that it's going to be 2 minutes for 360 degrees. So our revolutions per minute, we have 1 revolution, and it's going to take 2 minutes. So our RPM is 0.5 RPM, revolutions per minute. If I want to know what my radians per minute is, then my radians per minute is I take my 1 revolution for every 2 minutes, and I use my unity conversion, and I want to get rid of revolutions again, so I have 2 pi radians, 1 revolution. Revolutions cancel out, my 2's cancel out, and I am left with pi radians, just like before, but on this example it is pi radians per minute instead of pi radians per second. So I would like you to do example number 3 and 4. I'm going to go ahead and give you the answers, and then we'll go over them in class if you're not coming up with the same answers. On example number 3 and example number 4, they're giving you more information that you need. At this point, it doesn't matter what the diameter of the record is, and it doesn't matter how long the windmill blade at this point is. So you don't need that information until we get to linear velocity. So here's your answers for part 3 and 4. And thank you for watching.